Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are studying quadratic relations. It's a video about word problems in which you are not provided with an equation, rather you have to create an equation out of the words provided. It's question number 3 from that worksheet. So here's the question. It says a room can be considered a rectangular box. That's true. The length of the room is 6 meters, and the height is 1 meter less than the width. If the volume of the room is 72 meters cubed, find the dimensions of the room. So, what do we know? Well, I always suggest for my students to always reread, first of all, this last line. Find the dimensions of the room. So the dimensions of a room, so we're considering the room to be a rectangular box. So, like this. There it is, except for this happens to have a door and a window and a ceiling and so on. So the dimensions of a rectangular box are length, width, and height. So we know that when it says find the dimensions, they're asking me to find the length, the width, and the height of the room. So what do we know? Well, we're talking here about a known volume, which means we're going to be using the formula volume equals length times width times height. So now that we've thought about what's going on, let's start formally answering this question. And of course, formally answering a word problem begins by formally identifying your variables. So again, we have length, width, and height. So let's see. The length of the room is 6. Well, I know the length, so obviously I'm not going to assign a variable if I know the answer. So length is not x. The height is 1 meter less than the width. Okay, so we're going to let h be the height. Yep, I'm not using x and y this time. I'm using h. C'est la vie. So let h be the height measured in meters, and we're going to let w be the width, also measured in meters. So now I need to write an equation. Because I've introduced two variables, I must create an equation that tells me the relationship between the two variables. So go back and read and find where the relationship is between height and width. And it's right here. The relationship is that the height is 1 less than the width. So write that as an equation. The height is 1 less than the width. So I need to have the width, take 1 off of it, that's the height. So there's my relationship equation that relates the variables to each other. Now I need an equation that I can substitute into. So again, in addition to height and width, I also have a volume and a length. So I'm also going to be referring to volume and length because the equation we're going to use is obviously volume equals length times width times height. And again, I know volume is actually 72. Length is actually 6, and height can be written as w minus 1. So when I do all of those appropriate substitutions, I'll be left with something I can solve for. So here we go. Volume is actually 72. Length is actually 6. Width, well, that's just width. And the height can be written with respect to width. And that's important because now I have one equation and only one variable called w. So we'll keep that w alive. What? I don't even know what that means. So, wow. So we're going to work with that w and try to solve for it. I still have no idea what I was trying to say there. So I'm going to just deal with the w's for a second. So w times w is w squared. W times -1 is negative w. So rather than multiply by 6, I'm just going to divide both sides by 6, just so that I can get rid of that multiplication by 6 and work with some slightly smaller numbers. So 72 divided by 6 is 12. So I have 12 equals w squared minus w. And as always, if you're working with quadratics and you're trying to solve, you need to make your equation equal to 0. So there's my equation. Solve, certainly you can use a quadratic equation, but this looks easily factorable, so let's just factor. The two numbers that multiply to -12 and add to -1 are -4 and +3. So I factored. So therefore, this could be equal to 0, or this could be equal to 0, And either case, I would have a true statement. So if w minus 4 was 0, that means w equals 4 is a solution to this equation. Or if w plus 3 was equal to 0, w would be negative 3, which is a solution to this equation. So there's my two solutions. Let's take a look at them. What was w again? Well, w was the width of a room. So it was something measured. We don't measure negative meters. I don't even know what that means. So we put a single line through that and say it's inadmissible. So remember, it doesn't mean it's wrong. Wrong implies you've made a mistake. Inadmissible means that the math is correct, but this particular answer is not allowable as a potential solution to the question asked. Inadmissible, not allowed. So therefore, I'm left with w equals 4. So let's work with w equals 4 and see what that gives us. So if w equals 4, what does that mean about height? So we use this relationship equation from the very beginning, and we calculate height. So we know that height is width minus 1, so the height is 3. So we were already given in the original question the length, so we could say, therefore, the dimensions are 6 meters length times width, which is 4 meters, times height. So typically, when you're talking dimensions of a three-dimensional cube, you do length, width, and height. So 6 times 4 times 3. And of course, it's very easy to check and make sure that we have a volume of 72. 6 times 4 times 3 is, in fact, 72 cubic meters. Okay, so hopefully a fairly straightforward word problem involving quadratics. That was question 3, and I'll meet you maybe at question